this video, I'm going to talk to you about practical applications of linear graphs. So what we're going to do is we're going to find a rule that connects variables together. So look at the top graph here. We can see it's got a positive gradient, and we can see that there is a rule y equals 3x plus 5. We can see that as the x variable increases, so does y, and we can also see that the line has a positive gradient. Now what this means is that if two variables are linked by a rule, then one variable increases and so does the other. In this particular case, each time x increases by 1, y increases by 3, i.e. this rule 3x plus 5, where the gradient represents increasing by 1, increasing by 3. Now, if we have a look at the lower graph, the bottom graph, down here we can see that this shows as one variable increases, the other one decreases. And y is going down, so that gives us a negative gradient. Now, if we have a look at the rule, y equals minus 2x plus 7, we can see the gradient is negative 2. That means that each time x increases by 1, y decreases by 2, hence the gradient negative 2. So let's have a look at that, or let's have a look at some relationships and how we can model them using some tables. Alright, so here I'm going to do an example where we find the rule connecting x and y in each of the following tables. So here I'm going to look at a rule connecting the first table, x and y. If we look at x, we can see as x increases by 1, y is increasing by 5. So therefore that gives us our gradient. So let's write that m equals 5. We understand because it's a constant steady rate, it's a linear relationship. So we know that the rule that this follows is y equals mx plus c. We can also see from the table that the y-intercept is at negative 3, and that's because when x is 0, that's where our y-intercept is. So let's write that c equals a negative 3, and then we have the rule. All right, let's move on to table B. Let's look at B. Let's look at the relationship. As we can see, as y decreases at a steady rate, as y decreases by 1 each time, x increases by 1 each time, giving us the gradient of negative 1. We know it follows a straight line. It's got a constant steady rate, so we write the rule as y equals mx plus c. And let me just write that. Sorry, I've got that there. That's it. And I'll just write it over here because we don't know the value of c from the table. We don't know when x is 0. So what we need to do is substitute in one of the coordinates. I'm going to use the first one. When x is 3, y is 12. So let's substitute that into the rule and go through and solve to see if we can find the value of c. So adding 3 to both sides, the y-intercept is 15, so our rule is y equals negative x plus 15. All right, so I'm just going to now look at other modelling problems that we might come across. Now you can see here that we're looking at relationships that connect things in real life, so we don't use x and y variables. In this particular example that you can see here, we're going to use C for cost and N for books, but we need to identify if one variable is changing at a constant rate compared to the other, then the two variables do have a linear relationship. So we need to identify the linear relationship first. If that is the case, that they are changing at a constant rate, then it's going to be using the relationship of y equals mx plus c. A certain book for $21, and it charges a set delivery fee of $10. So that's our y-intercept. Our y-intercept is $10. That's where when we sell 0 books, it's going to cost us $10 to deliver. Now, every book we sell, for one book we sell, the cost goes up by $21. That's our y value. Our y value of a coordinate. So every single time it goes up by one book, it goes up by $21. So this is our gradient. So when we write this in terms of the variables, c represents our y-axis and n will represent our x-axis. and we'll come up with a rule. So the rule becomes 21n plus 10, showing our gradient as 21 and our y-intercept as 10, i.e. the books go up, for every one book, the cost goes up by $21, and there's a set delivery fee of $10. Now we've got to use the rule to find the cost of delivering 35 books. Well, that means when n is 35. So if we substitute when n is 35 into the rule and calculate the cost, we get the cost as $745. The final part of the example says how many books can be delivered for $1,000. Well, our cost is now $1,000, so we're going to put the equation equal to 1,000 and go through the process of solving. Now, we can't get 47.14 books, so we need to look at our answer and say, well, how many books could we get for 1,000? Only 47. If we wanted 48 books, we'd have to have more than $1,000, so it's 47 books. Okay, guys, that's all you need to know.